Hello, welcome to today's session. My topic today is Ethereum object format, EOF, necessary evil or needless complexity. And before the session starts, please let me briefly introduce myself. My name is Luis, and I'm a white hat from DeFi Hack Lab. DeFi Hack Lab is the biggest Web3 security community globally, and we're excited to have you all here. And DeFi Hack Lab is also the place where I conduct attack incident analysis, and we also have a security bootcamp, and I'm glad to be part of the instructors. And I also like to conduct audit, join audit competition on different platforms, especially Cantina, and sometimes I join CTF challenges also. Yes, and my topic today is EOF. EOF is not the abbreviation of end of file. It stands for Ethereum object format. And here, before dive deep into EOF, we could have some background knowledge in EVM. EVM stands for Ethereum Virtual Machine. And you can view it as the engine for all the smart contracts to execute on Ethereum ecosystem. When a blockchain is EVM compatible, it uses the same instruction set as Ethereum mainnet, including layer 1 and layer 2. And in other ecosystems like Solana, they use SVM. And for Aptos or Sui, they use MoveVM. And come back to EOF. EOF is an enhancement of EVM. It includes more than 15 EIPs, and the definition, the specification is defined in EIP 76 and 92. And here is this is an awesome list. If you want to know more about EOF, you could check this awesome list. All right, and what is the current status of EOF? First, we could take a look at the Ethereum upgrade timeline. We already have Petra upgraded in May this year, and Fusaka is scheduled in November this year also. And after that, we will have Glamsterdam, maybe in Q2 next year. EOF, it was originally scheduled in Petra, but because Petra is too large, so it is moved to Fusaka. But during the discussion, there is a heated debate against EOF. So now it was removed during an interrupt testing meeting. And this process is unusual because in a typical Ethereum decision-making process, this big decision usually are made during ACDE for execution layer meeting, but this decision is made during an interrupt testing meeting. And there are a lot of dramas going on during the EOF discussion. And what is these dramas? This is a timeline for the discussion. At the very beginning, initially, all core dev, ACD, they believe that EOF is a huge enhancement for legacy EVM because it could resolve so many long-standing issues for legacy EVM. But after the community start to really look into the EOF design, they think that EVM should remain simple, and EOF is too complicated. And some security members from CO 911, they emphasize that if the EOF design is too complicated, it might introduce some potential security issue in the design. So we should also, so they also emphasize that EVM should stay simple. And if you are interested in his statement, you can check this article. So in order to respond to community's concern, the Epsilon team who proposed EOF, they roll out 4 different types of EOF. type A to type D EOF. And after weeks of discussion, all core dev, again, they almost reach a consensus to ship the type D EOF. But before the final decision, at the last minute, Res and Aragon, they are one of the Ethereum client team. They regret on their decision. And they decided they do not want to upgrade to EOF. They want to completely remove EOF from the future Ethereum upgrade. So the final result is that EOF is removed from Fusaka upgrade. And I think in the future upgrade, like Glamsterdam, EOF will never happen. So we talk a lot about the dramas in the EOF decision, and we could come back to see why, we could come back and first check why we need EOF and what is the disadvantage for EOF upgrade. All right, so the first problem in legacy EVM is that there's no versioning or structural layout for legacy EVM contract, the bytecode. There's no ELF header like in Linux, we have ELF header that specify the version and some related information. But in legacy EVM, there is no similar feature. And this makes it hard to deprecate some legacy opcodes. For example, in the past, Ethereum Foundation and the community really want to deprecate the self-destruct operation because it is very dangerous. But because there is no versioning, so it makes it really hard to do this. And the other problem is that there's no code validation during deployment time in legacy EVM. So you could deploy undefined or invalid bytecode onto the Ethereum mainnet. As a result, the first improvement for EOF is to introduce a container structure that provide a structural layout and versioning header. This is the container for EOF. In a container, there are two parts. The first part is the header, and the second part is the body. And you can see in the header, there's a magic value that tell you this bytecode is EOF compatible. And this version, the following byte is the versioning. So you can see this is the first version of EOF. And if in the future we want to deprecate some opcode, we could check this version to see whether this opcode is activated in this specific version. And for the layout, in EOF, there's different sections. For example, we have type section, code section, and data section. And in the past, all the code and data are all within the same bytecode. But now the code and data section are separated. Okay, we will come back later for more detail in this structure. Let's go to the second problems in legacy EVM. The second problem is that EVM uses dynamic jumps over static jump. And the relevant operation is jump and jump I for conditional jump and jump dest. And if we want to do better program analysis, that static jump would be more helpful. And static jump would enable us to do better function boundary definition and label more clear function arguments and also improve the control flow analysis. For example, reconstructing the control flow graph. And tools like static analyzer or fuzzing tool or formal verification tool would benefit from this static jumps feature. In legacy EVM, if you want to define the function boundary, you need to detect two patterns. One pattern is the call pattern, and the other one is the return pattern. Here we could take the code pattern, for example. If we want to identify a code pattern, it would be a push and a jump operation. So this is a simple example. This is an internal function code. But if you want to know the return address for this internal function code, you need to identify this push operation, and this is the return address. And it will be difficult because there might be extra operation in between. So you might need to use some tricks or some algorithm to decode this value. All right, this is one problem for defining the function boundary. And the second problem is that if you want to decode the input argument numbers or output argument numbers, you need to execute the bytecode in green. You need to calculate the state changes in this area. And that would be the input argument numbers for the following function. And how do EOF solve these problems? For the first one, the call and return pattern, they use different operation. For call, it is split into call F and jump F. Jump F is for non-returning function. And for the return operation, it is replaced by the return F opcode. And a new component is introduced to EVM. It is called the return stack. And whenever, in the past, you need some algorithm to define the function's boundary. But now we have a structural format like this one, and we have code section. And each code section now represents one function. So we no longer need to decode the function boundary because each code section now represents one function. And when you want to know the return address for each internal function code, you could directly check the return stack item. When we want to do an internal function code, there will be a call F operation following by the code index you want to jumps to. And the return address will be pushed onto the return stack. And when you do the return, the EVM will pop out an item on the return stack and then jump back to the specific code section. So the function boundary problem is solved in EOF by these three operations. And for the input argument numbers and output argument numbers, they are solved by the type section in EOF. We already introduced the code section, and there is another section called the type section. And in type section, each 4 bytes represents the input argument numbers and output argument numbers and max stake increase for the corresponding code section. So when you're doing the program analysis, you can directly read the information in type section and label this information in each code section. It would be more easier for tooling developer. All right, and let's move on to the third problems in EVM. If you are a smart contract developer, I think you must see this error message before. It is called stack to deep. And why do we have stack to deep issue? Because when you are passing arguments to a specific function, you will push these parameters onto a stack. And when you want to access this value on the stack, you would use this operation. You might use swap 1 to swap 6 or dupe 1 to dupe 6. And it is too limited because you can only access up to 16 levels deep in the stack. But when your items are not within this range, it will trigger this error. In EOF, 3 new opcodes are introduced. The first two is the dupe end and swap end. They extend the stack access limit to 256 levels deep. And the third one is exchange. It allows you to specify two positions on the stack and directly swap the items on the stack. So how will this improve the EVM? You could check this stack ordering here. We originally have the stack ordering A, B, D, C, and we want the final result to be A, B, C, D. In the past, we need 3 swap operations. So the first one is swap A and C. The second one swap C and D. And the final one swap D and A. And you got A, B, C, D. But now you could specify you want to directly swap D and C. So the final result would be the one we want. So the same result, but now we only need one operation. That's how this EIP improves the legacy EVM. Okay, and to summarize, there are some long-standing issues in legacy EVM, and EOF tries to resolve this issue by introducing structural layout and versioning headers, and also they introduce static jumps to replace the dynamic jumps. And for the stack to deep issue, they extend the original opcode to access more items on the stack. And to achieve this feature, EOF deprecates 7 legacy opcode and introduce more than 15 new opcodes. You can check this table for the deprecated opcode. All the code-related operations are deprecated, but there are replacements for them. The code is replaced by ext code, and you could check this similar operation, the similar replacement for this code operation. And the jump operation are also deprecated. Like we already mentioned earlier, they are replaced by the co-F, jump F, and return F for the static jump. And create and create2 are also deprecated. So if you're using some contract creation factory, you could no longer use them. Okay. And this chart shows that in order to test EOF in the DevNet, in order to test EOF in each client implementation, Ethereum Foundation created a lot of DevNet to do so. But in each DevNet, they found new issues in current specification or the current design. So they need to introduce new EIP to resolve this issue. So far, we introduced so much features that is introduced in EOF and how they improve the EVM. Now EOF looks good because we will no longer have stack to deep. We will have versioning header, and we will be easy to deprecate opcodes. If EOF improves the legacy EVM so much, why are some people still opposed to these changes? So let's talk about the problems in EOF. The first problem is that there's no clear time schedule for EOF. Here are some tooling or development stake for Ethereum ecosystem. If you are a smart contract developer, I think you're very familiar with these tools. We have compiler, we have Solidity compiler, and we have Viper compiler that allows you to write a smart contract language that looks like Python. And we also have Half compiler that allows you to write low-level assembly smart contract. And we have development tooling like Hardhat and Hard Foundry that allows you to write a unit test framework and also doing the fuzzing test. And there are other tools like Web3.js, Ethereum.js that allows front-end developer to integrate the smart contract interactions into their front-end framework. And we have security tooling, for example, bytecode analysis tool, or fuzzing tool, or formal verification tool. And for smart contract development, we have very well-known Open Zeppelin libraries that allows you to reuse a lot of popular ERC, like ERC20, ERC 721 for NFT. But just imagine if EOF is upgraded on Ethereum mainnet, but these toolings are not upgraded accordingly, what would happen? When you are writing smart contract, you want to compile, but you compile your compilation generate the legacy EVM bytecode. Your bytecode cannot be deployed on Ethereum mainnet, so everybody cannot deploy the bytecode. And the problem is that there is no much effort put on coordinating this tooling development. So we don't know whether when Fusaka is complete, this tooling will upgrade to the latest version to be EOF compatible. And the second problem that here is there is no clear benchmarking for EOF. When developing EOF, people argue that EOF will save a lot of compilation time because there is static jump that could help this tooling faster, and we have exchange or similar opcode that can reduce the operation count. But how much compilation time will it actually reduce? And how much bytecode size will EOF actually reduce? There's no clear benchmarking. People just talk about it might reduce or it might have some benefit, but there's no clear benchmarking. There's no comparison before and after EOF. And the third question is that in the future, Ethereum will adjust it to ZKVM architecture or the Lynchon architecture. So it will use ZKVM to do the proving. And will EOF be, will the ZKVM benefit from the EOF upgrade? There is no clear benchmark for that. And I remember Viper even do an analysis on this. They compare the EOF upgrade to the Viper generated legacy EVM bytecode to see whether which has better performance for ZKVM. And the result is that the Viper generated EVM bytecode is much faster or a little bit faster than EOF. And the final one is in each newly added EOF opcode, how does this guest code being defined? I believe that there is no clear benchmarking because I'm currently contributing to the benchmark for Ethereum. And before I joined, I did not see any benchmark for EOF. So it would be very dangerous because if a opcode is mispriced, you could generate a block full of the specific opcode. If the block executes more than 4 seconds, this might harm the entire blockchain consensus. So that might break Ethereum's 100% uptime record. And the third problem in EOF is that there's limited impact analysis on backward compatibility. We deprecated create and create2 opcodes in EOF, but there are so many tooling or so many factory using this using the create2 pattern. But the new opcode EOF create it has totally different patterns from create to. So some existing smart contract patterns will break. And for the ext code, it no longer accepts the gas as a parameter. But if you are a smart contract developer and you have integrated cross-chain bridge before, you know that there is a parameter called callback gas limit. If we could not pass the gas as a parameter to the external code, then the cross-chain bridge no longer can restrict the callback gas limit. They will need to find workaround for that. And there is more related instance for this. And the other concern is that we introduced so many features in EOF, but do we really need all these features? For Viper, they don't have stack to deep issue because they resolve this issue by better memory management skill. And the second problem is that the specification keeps changing. Like I showed before, in each DevNet, they will discover new issue, and there are new challenges that needs to be solved. So there might be potential security issue in each improvement or in each new EIP. So that is very dangerous, and there might be some vulnerability we cannot discover during testing or implementation phase. And the third one, I think, is the most important one, because even if you upgrade to EOF, you still need to maintain a legacy EVM. So for client developer, there will be maintenance effort. And for the beginners in Ethereum ecosystem, they need to learn the two versions of virtual machine. And it is a lot of effort. And in the future, we might introduce RISC-V or other instruction set. Then people need to learn 3 different virtual machines when you want to write some secure smart contract. So the final decision is to remove EOF during that meeting. And the idea is that we don't want to be risky to such big changes that might break Ethereum's 100% uptime. And the second one is that there's not much backward compatibility analysis. So this change might break some applications assumption. And the third one is that Okra Dev, ACD, their main focus for Fusaka this year would be pure DAS to scale the blob scalability. So we should not let EOF delay the progress for pure DAS. And this ends my presentation today. Thank you very much. I think this is very big topic, so it's really hard to introduce all the features and all the trade-off within one talk. So if you're interested in EOF or the Ethereum's virtual machine, we could discuss after this talk. And I'm from DeFi Hack Lab. Thanks you very much. Oh.
Okay, thanks to Lois' talk. And here, do you have any questions about the EOF or other some cool things?
我可以用中文问吗？
可以啊，可以啊。
我有一个我不知道，可能有点 stupid， 但是有点小，就是刚刚你有说什么，就是他如果上只是一个小问题，你说4秒，然后可能会 break 100% 的 uptime， 那这个4秒的这个数字是怎么来的？
这个其实我没有到非常确定，但是就是这是跟以太坊的有一些 background 是以太坊它是分为 execution layer 跟 consensus layer， 然后这跟 consensus layer 那边 slot 的一些设计有关系，所以他们现在在加入新的 upcode 的时候，他们会需要去做 benchmarking， 然后去确保说，如果我在 我如果创建一个 block，然后里面全部都是这个 opcode， 它运作的时间会不会超过一个特定的时期？因为如果你超过这个特定的时期的话，可能会导致后面它在决定区块的下一个 block 会出现问题，这是我目前的理解。所以那个就是它有一个 time limit 这样子。
哦，
对，但它就是比较偏 consensus 的那一个 part。
了解。好，谢谢。
是不是 Nick 可以协助解惑吗？就是4秒这个部分的话，好，我可以回去查一下。但我记得，上一期的 ACDT 我们在分享的时候，大家就是特别关注这个4秒左右的这个时间，这样。好，我可以再研究一下。好，那还有其他问题吗？
Okay, so thanks to Lois' talk,